Welcome to problem lesson 27, and these are the 10 problems that we have to solve. This lesson is about problems involving a base other than e, base 3, base 10, etc. And it's about logarithms and exponential functions like 5 raised to the x or raised to the minus x. And these are the derivative of these functions and the integrals of these functions. Okay, let's go to solve the 10 problems. We start with the first one. It's if logarithm in base 3, if logarithm in base 3 of a number x is equal minus 1, which is the number. To find out which is the number, you will not do e to the logarithm of x. No, you will do 3 to the number. 3 raised to the number will produce, because 3 to the x, a logarithm in base 3 of x. They are inverse function. 3 raised to log of base 3 of x. This is x. And on the other side, I have 3 raised minus 1. So the x is 1 divided by 3, positive. Okay. This is, this is the result. Now, next problem. It says solve for x. So you have an equation that says that x squared minus x is the log in base 5 of 25. Who is x? Well, log in base 5 of 25 is a number c, which is 5 raised to the c. The base raised to the c is the number 5 squared. So from this equation, I can see that theta is equal to. So now I can write the equation. X squared minus x equal to. And I can solve for x. How? Using the quadratic equation. X squared minus x minus 2 equals 0. So the x will be, I may factor this expression like x minus 2 by x plus 1. X plus 1 equals 0. This is the factorization of this expression. So x equal plus 2 and x equal minus 1 are the solution. So when I have the equation x squared minus x equal 2, if I place the number 2 here, 2 squared minus 2 will be 4 minus 2, so it's true, is equal to, and minus 1 squared minus minus 1 is also 2. So I solve it. Let's go to the next one, number 3. Now we need to find x in this equation. 3 raised to the 2x equals 75. 3 to the 2x equals 75. What we will do? We will apply the inverse function of 3 to the x. The inverse function of 3 to the x is the function log base 3 of x. So log base 3 of the number 3 to the x is equal log base 3 of 75. Now we will apply the properties that the log in base 3 of 3 to the x is the number. So it will be 2x equal log base 3 of 75. And now x will be log base 3, 75 divided by 2. And this is the final solution. If you take your calculator, maybe this is around 2, maybe. Okay, so let's go to do this problem. Find the derivative of a raised to the minus 4x. So now I have a function in the exponents. So if I have the x, the derivative respect to x of a to the x, we learned during the class, that is a to the x by the natural logarithm of a. If you have a function a to the u, where u depends of x, the derivative respect to the x of a to the u is a to the u multiplied by the natural log of a by u prime. Now, let's go to apply this formula to this problem. Now, u to the x, u of x is minus 4x. So the derivative of u respect to the x is minus 4. So the derivative respect to the x of the function 5 minus 4x is equal 5 minus 4x by the derivative of u respect to the x, which is minus 4, by the natural log of 5. And this is the final expression. Now we have another function, x multiplied by 9 raised to the x. The exponential function is 9 to the x. How I can do this problem? I may do it in two different ways. Let's go to do it in the first way. The first way is to consider that f of x is the product of two functions, the x and the 9 to the x. So the derivative of the function respect to the x is the derivative of the first 1 by the second 9 to the x plus the first x by the derivative of 9 raised to the power x is 9 to the x multiplied by the natural log of 9. And the problem will be solved. We can reduce this like 9 to the x that multiply 1 plus x log of 9, and the problem is solved. The second way to do this problem maybe is to write like this. Y of x is x 9 to the x. This is y. Let me take the natural log of y. The natural log of y will be the natural log of x multiplied by 9 to the x. So the natural log of y equal, I will apply the property of the natural log, that is the product, the natural log of a multiplied by b is the natural log of a plus the natural log of b. So this will be the natural log of x plus the natural logs of 9 to the x. Now, instead of taking the natural log, let me do something better. Let me take in this expression, let me take log base 9 of y. Log base 9 of y will be log base 9 of x multiplied by 9 to the x. So, what I have is that log base 9 of y is log base 9 of x plus log base 9 of 9 to the x. And now, what is log base 9 of 9 to the x? Is the x. So the equation will read like follows. Log base 9 of y equal log base 9 of x plus x. Now I will take the derivative. What is the derivative of log base 9 of y? The derivative of log base 9 of y is 1 divided by y by the natural log of 9 by the derivative of y respect to x equal log 9 of x. What is the derivative? I'm taking the derivative respect to x of this expression. 1 divided by the function by log of y, by log of 9 divided by. And now the derivative of log of 9 is 1 divided by x by the natural log of 9 plus 1. And this will allow me to find the derivative of y respect to x. It's a more difficult procedure, but we will use this technique to find the derivative of y respect to x for some inverse functions. So what is the derivative of y respect to x? The derivative of y respect to x is equal to y log natural log of 9 multiplied by 1 divided by x natural log of 9 plus 1. And what is y? Y is the function x 9 to the x. Okay, let me put the function here. Instead of writing the y, I will put the function with this I said that is what is the function x 9 to the x, x by 9 to the x. So let me put this better. Now let me so I'm sorry. Okay, it will be the derivative of y respect to the x will be y, I said that is x multiplied by 9 to the x by the natural log of 9 multiplied by 1 divided by x by the natural log of 9 plus 1. And now let me see if this is the same thing that before. Let me check here. So the derivative of y respect to the x will be the x and the natural log of 9 will cancel. It will be 9 to the x plus x 9 to the x log of 9. And now let me see what was the result for the first part to check that is the same result. 9 to the x plus x 9 to the x, or let me put it in this way, 9 to the x that multiply 1 plus x natural log of 9. Natural, okay, 9 to the x, let me see. Yes, it's the same one. So the second part is more difficult, but you will need this strategy to do the derivative of inverse function. Let's go to the next one. Now let's go to do the derivative of this function. This function is f of x. Let me put it in white, it look better. F of x is the derivative, f of x is log base 5. Always that I put in capital letters natural log, it refers to the base e. Here is log base 5 of a square root of x squared minus 1. So you know that the 1/2 can come up. So it's the same thing. So we need to find the derivative. When you have log of x, the derivative, if you have y equal log of x, log in base b of the number x, the derivative of y respect to the x is 1 divided by x divided by the natural logs of the base b, or a, well, the base b I was talking, of 5. So if I have y, if I have y equal log base b of a function of u of x, the derivative of y respect to the x is 1 divided by the function by the natural log of b multiplied by the derivative of the function. So let's go to apply this equation to find the derivative of the function that is the problem. So I will start with y equal log base 5 of x squared minus 1, 1/2. And the derivative of y respect to the x will be 1 divided by the function. The function is x squared minus 1, 1/2. Multiplied by the natural log of the base, 5. And multiply here in the numerator by the derivative of u. U in this case is x squared minus 1 and raised to the 1/2. And the derivative of u respect to the x is 1/2 x squared minus 1 multiplied by 2x. So the 2 will cancel, these 2 will cancel, and I will have that the derivative of u respect to the x is x squared minus 1 multiplied by x. So I have to put this derivative here, x squared minus 1 multiplied by x. As a conclusion, I have the derivative of y respect to the x equal 1 divided x squared minus 1, 1/2 multiplied by x squared minus 1, 1/2. This is this term. Okay, multiplied by x divided by x squared minus 1, 1/2 multiplied by the natural log of 5. Now what I did is that this term will cancel, will produce a 1. So the derivative of y respect to the x will be the derivative of y respect to the x will be x squared minus 1, 1/2 multiplied by x divided by the natural log of 5. But I did a mistake. The derivative of u respect to the x, the derivative of u respect to the x is 1/2 x squared minus 1 raised to the power 1/2 minus 1, which is minus 1/2. Let me correct here, minus 1/2. So let me correct, I'm sorry. So it will be x squared minus 1 by x, yeah, and here is minus 1/2. And now it would be, let me erase, okay, let me erase and do it correctly. Sorry. It will be, the minus 1/2 will go to the denominator and will produce x squared minus 1 raised to the power 1 multiplied by the natural log of 5 And here is the x, and this is the final result. Now we go to problem 7. Find the tangent line to the graph y equal log of 10 of 2x at the point 5, 1. The point is the point 5, 1 or x0, y0. And the tangent line that they are asking me is the equation of the rectilinear line that pass through the point 5, 1. And the equation of a rectilinear line is y equal y0 plus the slope multiplied by x minus x0. What I do not know is the slope. But the slope, because y of x is the log inverse 10 of 2x, I will find the slope at x equal 5. The derivative of y respect to the x is 1 divided by the function multiplied by the natural log of 10 by the derivative of the function, 2. So this will be 1 divided by x natural log of 10. And this is the derivative. But I want the derivative of y respect to the x at x equal 5. So the slope of the graph of log of 10 of 2x, the slope of the graph at x equal 5 will be 1 divided by 5 by natural log of 10. Natural log of 10 is a number, 10 is a number bigger than e, so natural log of 10 is bigger than 1, maybe 2 something. Okay, so this is a number, the slope is around 110, more or less. I don't know, we should use the calculator to find this number. But the problem is not solved yet. The problem is asking what is the tangent line. The tangent line is y equal y0 plus the slope at the point by x minus x0. So putting numbers, the y0 is 1, the slope is 1 divided by 5 natural log of 10 multiplied by x minus x0. x0 is 5. So it will be y equal 1 minus 5 divided by 5 natural log of 10 plus 1 divided by 5 natural log of 10 by x. This is the equation of the rectilinear line. Now is another problem is find the indefinite integral. Find the antiderivative of 5 minus x, 5 raised to the minus x ddx. So to do this problem, we remember that any derivative equation takes rise to an integral equation. So let's go to do it in this way. The derivative respect to the x of a to the x is equal to a to the x multiplied by the natural log of a. Perfect. But here it appears not the x, it appears minus x. So the function u is minus x. So let's go to write another equation. The derivative respect to the x of a to the u is equal to a to the u by the natural log of a by the derivative of u respect to the x. And this equation yields to another equation that is an integral equation. How? We make the integral in both sides. So the integral of the derivative with respect to the x of a to the u ddu is equal to the integral of a to the u natural log of x by ddu ddx ddx. Okay, so the integral of a to the u, this ddx, it goes out with this ddx, and now the integral of this will be the integral of a to the u ddu. A to the u ddu will be 1 divided by the natural log of a, 1 divided by the natural log of a, by a to the u, by a to the u. This is the integral. Okay, let's go to apply this equation. So to apply this equation, we have that the u of x is minus x, and the a is 5. So I will write this equation in terms of what is a and what is u. It will be 1 divided by the natural log of 5. 5 raised to the u minus x equal the integral of a to the u 5 minus x by ddu. But ddu is minus 1 ddx. ddu divided by ddx is minus 1, then ddu is minus ddx. Okay, now I will say, wow, but the integral that I want is 5 minus x ddx. This is the integral that I want. And this is equal to this, with the minus sign going out of the integral. So the integral of 5 minus x ddx, the integral of this will be the minus sign will go to the other side and will be minus 1 divided by the natural log of 5, 5 raised to the minus x, and this is the integral. And there is something that is now I have to add because it's an indefinite integral, plus c. So the result will be this one. Now let's go to do this problem. Is the integral, indefinite integral of x cubed plus 3 minus x ddx. Well, x cubed is easy to integrate. So x cubed is x4 divided by 4. So what we have learned from the last problem? We have learned that the derivative respect to the x of a raised to a function f of x is a to the f of x multiplied by f prime of x by the natural log of a. So this equation yield, it takes you to an integral equation that say that the integral of the derivative of x respect to x of a to the f of x, the integral of the derivative is the function a to the f of x, is the integral of this expression. So working with this expression, natural log of a is a constant. I can take it out. I can put it here, and from here I can put it on the other side of the equation, like 1 divided by natural log of a. So 1 divided by natural log of a is a to the a of multiplied by a to the f of x is the integral of a to the f of x multiplied by f prime of x by ddx. So let's go to plug in the numbers. A to the f of x is 3 raised to the minus x. F prime of x is minus 1 because f of x is minus x. F of x is minus x, so f prime of x is minus 1. So the equation will be the 1 divided by the natural log of 3, by 3 minus x will be the integral of 3 minus x by f prime of x minus 1 ddx. So this minus sign will go to the other side. So the integral of 3 minus x ddx, that is what they are asking me here, it will be minus 1 divided by natural log of 3 multiplied by 3 minus x. And the problem is done because now you know that the integral of 3 minus x is this, then the final solution is x to the 4 divided by 4, that is the integral of x cubed. The integral of 3 minus x ddx is 1 minus 1 divided by log of 3 multiplied by 3 minus x plus c. So this is the solution to the problem x3 ddx plus the integral of 3 minus x ddx. And the problem is solved. Now we are going to solve problem 10 that say do the definite integral from 1 to e of this function 6 to the x minus 2 to the x. Of course, you cannot make the difference between 6 to the x minus 2 to the x. You have to do the integral of 6 to the x ddx minus the integral of 2 to the x ddx. So what is the equation that we will use? The one that we have found in the previous problem, that say that the integral of a to the f of x by f prime of x ddx, the integral of this expression is a to the f of x divided by the natural log of a. In this case, the a is 6, the f of x is x, so we need to do the integral of 6 raised to the power 6 raised to the x ddx. When f of x is x, so the derivative of f respect to x is 1, so the integral from 1 to e of 6 to the x ddx is 6 to the x, because f prime of x is 1, there is a 1 here, is 6 to the x divided by the natural log of 6. Same thing for the integral of 2 to the x from 1 to e, is the integral is minus 2 to the x divided by the natural log of 2. So the integral, the whole integral is 6 to the x natural log of 6 minus 2 to the x natural log of 2, evaluate between 1 and e, and if you do the evaluation from the value of the function of the antiderivative at e, so it's 6 to the e divided by natural log of 6 minus 2 to the e divided by natural log of 2 minus evaluate the antiderivative at x equal 1. 6 to the 1 divided by the natural log of 6 minus 2 to the 1 divided by natural log of 2. It's again the same application to a very similar problem. Now this problem we will see later. I will show you later. Let's go to the next problem. The next problem say find the use logarithmic differentiation to find the derivative of y respect to the x when the function is y equal x sine of x. So we need to use logarithmic differentiation. So what we do, we take logarithms in natural logs of y in both sides of the equation. So the natural log of y will be the natural log of x sine of x. Now, applying the property of the logarithm, the sine of x will go downward. We'll take it downward. So it will be natural log of y will be sine of x multiplied by the natural log of x. Now we do the derivative in the right side of the equation and the derivative in the left side of the equation. That is the product of two functions. The derivative in the left side of the equation is 1 divided by the function by the derivative of the function. 1 divided by y by the derivative of y respect to x equal the derivative of this product is the derivative of the first cosine of x by the second plus the first by the derivative of the second 1 divided by x. So now I can find dy dx y prime is y cosine of x natural log of x plus sine of x multiplied by 1 divided by x. But y is x sine of x. So I will introduce the value of y, which is x sine of x, and I will have this expression. So I have to evaluate the derivative of y at the x equal pi divided by 2. Of course, if x equal pi divided by 2, y should be pi divided by 2. Because it will be x sine of pi divided by 2 is 1. So it will be, when x is pi divided by 2, y of pi divided by 2 is x pi divided by 2 sine of pi divided by 2. But sine of pi divided by 2 is 1. So it's pi divided by 2. So the point that we are considering is the point x pi divided by 2, y pi divided by 2. And they say find the slope at the point x equal pi divided by 2. If I introduce the value of pi divided by 2 in my final expression, will be pi divided by 2 sine of pi divided by 2, which is 1, plus cosine of pi divided by 2, which is 0, by the log of pi divided by 2, whatever it is, 0 by something is 0, sine of pi divided by 2, which is 1, 1 divided by pi divided by 2, which is 2 divided by pi. So it would be pi divided by 2 multiplied by 2 divided by pi. So the 2 will cancel, the pi will cancel, and it will be 1. So the slope is 1 at this point of this function. The slope at x equal pi divided by 2 of the function y equal x sine of x, the slope is 1. And we have finished.